Okay, 3.5, solving a linear system using Gauss and Gauss-Jordan elimination method. Okay, two methods that we are going to learn now. First is Gauss elimination method. Second is Gauss-Jordan elimination methods. Okay, for Gauss elimination methods, we are going to reduce the augmented matrix until RE form. Okay, for Gauss-Jordan elimination methods, we are going to reduce the augmented matrix until RRE form. Okay, so that's the difference between Gauss and Gauss-Jordan elimination method. Okay, first, what is augmented matrix? Okay, let's say we are given a set of system equation like minus 5z equal 1, then 2y plus z equal 2. Okay, so this is the coefficient for this given system of equation. Okay, for coefficient matrix, so this is coefficient matrix. We form augmented matrix, mean that we have to transform the system of equation into this type of matrix, and this is called augmented matrix, where the last column is the right hand side value, this one. Okay, so for A, for matrix A, so A is given like augmented matrix is given in this form. Okay, so A is 2, 3, 0. 0 says there is no coefficient for x. Okay, 4, 5, 2, 4, 5, 2, and then minus 2, minus 5, and 1. Minus 2, minus 5, and 1. Okay, on the right side value is the last column, the right side value, 2, 1, and 2. Okay, so for Gauss elimination method, okay, for Gauss elimination method, we need to reduce this into RE form. Okay, RE form meaning that we have a triangle matrix like this. Okay, first we need to set. Okay, we need to set this to 1. Okay, so it means that so the one given here, so you can see here. Okay, we need to set this. We need to set this into 1 by divide the first row by half. Divide or multiply first row by half. Okay, so divide by 2. So divide by 2 here, it becomes, first row become 2 divided by 2, 1, 4 divided by 2, 2, and minus 2 divided by 2 is minus 1, 2 divided by 2 is 1. Okay, once we obtain, okay, the rest, row 2 and row 3 remain the same. Okay, now we focus on this one and make this, the rest of the column member for the leading one, the rest must be 0. And then this one must be 0. So how to make this 0? By using ERO, which is row 2 minus 3 row 1. Row 2 minus 3 row 1. Or it can be otherwise. Okay. Okay. So I think this one. Okay, better follow this one. Better follow this. I think there is a number of ways of ERO that you can perform, but I like to do it this way. Okay, for row 2 should be row 1 divided by 2. Okay, so row 1 divided by 2 will become 1, 2 minus 1 and 1. Okay, here is the same, 3, 5 minus 5, 1, 0 to 1 and 2. Okay, next is difference must be 0. So row 2 is row 2 minus 3 row 1. Okay, row 2 minus 3 row 1. So now row 1 remain the same. So the row 2 will be changed. Okay, 3 minus 3 row 1 is 0. 5 minus 6 is minus 1. Okay, 5 minus 6 minus 1. Minus 5 plus 3 is minus 2. Okay, minus 5 plus 3 is minus 2. Okay, here 1 minus 3 is minus 2. Okay, 1 minus 3 is minus 2. Alright, okay. Okay, next, this one is 0. Alright, okay. So, we have 1, 2, 1 and 2. Alright, so next one, this one must be 1. So, row 2 is minus 1 row 2. Okay, so we have 1, 2 minus 1 and 1, 0, 1, 2 and 2, 0, 2, 1 and 2. Alright, so next this one must be 0. So row 3 is row 3, plus 2 row 2. Okay, so we have 1, 2 minus 1, 1, 0, 1, 2 and 2. Here is 0. This should be minus. This one I mistakenly took this one, so it should be this one. So minus R3 minus 2 R2. 2 minus 2 becomes 0. 1 minus 4 is minus 3. And then 2 minus 4 is minus 2. Right. So next, this one must be 1. Okay. So this one must be 1. So we have R. Actually, this one is already in the RE form. Right, it's already in my form, but for simplicity, we change this into 1. So R3 is minus 1 over 3 R3. So we have 1, 0, 0, 2, 1, 0, minus 1, 2, 1, and 1, 2, and this one is 2 over 3. Okay, so here we've change back into system of equation. This one is Z. Z is 2 over 3. Okay, here is Y. Y plus 2Z is 2. Okay, so now substitute. This is called back substitution. Okay, this is called back substitution. Okay, now Y plus 2. 2 over 3 is 2. So we have Y plus 4 over 3 equal to Y is minus 4 over 3. So this is 6 minus 4 is 2 over 3. Okay, then here is X plus 2Y minus Z equal 1. So we have X plus 2, 2 over 3 minus Z minus 2 over 3 equal 1. Okay, so X plus 4 over 3 minus 2 over 3 equal 1. X plus 2 over 3 equal 1. X equal 1 minus 2 over 3 is minus 1 over 3. Alright. Okay, so X plus 2 over 3 equal 1. So now X is 1 over 3. So now to check whether your answer of X, Y, Z is correct, put in any of the equation here. Okay, for example, equation 1, 2x is 1 over 3 plus y is 2 over 3 minus 2z is 2 over 3. To check whether we've got 2 on the right side. So answer is 2 over 3 plus 8 over 3 minus 4 over 3. So answer is 6 over 3 equal 2. So correct. So this is how you check your answer of X, Y, Z by substituting in any of the equation here, and make sure that, your answer on the left and also on the right are the same. Done. So this is Gauss elimination method, where you reduce your augmented matrix, here, reduce until RE form. So this RE form. Okay, for Gauss-Jordan elimination method. Okay, for Gauss-Jordan elimination method, we further reduce the RE form here. This RE form, we further reduce the RE form to RRE form. Okay, we reduce it until RRE form. So now, reduce this, make this to 0, this one 0, and this one 0. Okay, so now to make this 0, R1, minus 2R2. Okay, R1 minus 2R2. So we have here 1, 0, 0, 0, and then minus 1, minus 1, minus 4 is minus 5. Okay, and then 1 minus 4 is, 1 minus 4 is minus 3. Okay, right, so here we have, the rest is the same, 2 over 3. Okay, next is, make this 0, this one. Okay, by do the ERO on the leading entry here. Okay, row 1 is row 1 plus 5 row 3. So we have 1, 0, 0, minus 3. Okay, minus 3 plus minus 3, minus 3 plus 5 times 2 over 3 plus 10 over 3. Okay, minus 3 plus 10 over 3, which is minus 9, 1 over 3. Okay, so we have 1 over 3 here. Okay, so next, this one, make this to, we write again. 0, 1, 2, and 2, 0, 0, 1. You can do at the same time for this one, okay? 2 over 3. Okay, now this one, row 2 is row 2 minus 2 row 3. So we have 1, 0, 0, 0, 1, 0, 0, 0, 1, 1 over 3, and this is 2 minus 4 over 3. Okay, 2 minus 4 over 3, 6. So 2 over 3 here, and 2 over 3 here. Okay, now straight away we get the answer. So this is x. Straight away we get answer, which is x. Which is x equal 1 over 3. Here y equal 2 over 3. And here z equal 2 over 3. For Gauss-Jordan elimination method, we straight away get the answer for x, y, and z. But for Gauss elimination method, we need to use the back substitution method in order to get x, y, and z. Okay, so that's the difference between Gauss-Jordan elimination method and Gauss elimination method. Remember, for Gauss elimination method, we reduce until RE form, and we need to solve back substitution method to obtain x, y, and z. But for Gauss For Gauss elimination method, okay, for Gauss-Jordan elimination method, we will reduce until RRE form. So this is RRE form. Okay, we reduce until RRE form and straight away obtain answer for X, Y, and Z. Done.